In this lesson, we're going to focus on vapor pressure and really specifically working with table H in our reference tables. So vapor pressure is the pressure exerted as the liquid is going to become a vapor. And we usually talk about this in terms of a closed container. Now, vapor pressure or liquid is not dependent on mass or volume. It's solely dependent on the type of liquid and the intermolecular forces that are occurring between the liquid molecules. Because in general, the stronger the attractive forces, the lower the vapor pressure is, because there's going to be less of those liquid particles moving upwards to become a vapor. Now, why do we care about vapor pressure? Well, it's related to boiling point. In a container, when the vapor pressure, which is those liquid particles pushing up to become a vapor, equals the atmospheric pressure, which are the air particles pushing down on the surface of the liquid, when those two are equal, the liquid is then able to actually boil it. And again, we're going to be going back to table H and dealing with this at the very end of this video. So this is an important point of why we usually want to look at and discuss vapor pressure. Now, a couple of things is because these two, atmospheric and vapor pressure, have to be equal each other in order to boil, if we change atmospheric pressure, that's going to then change the boiling point. So tomorrow in class, we're going to be talking about some examples of what happens. So if we decrease the pressure over liquid, such as going to a higher elevation, the boiling point actually goes down because there's not as high of an atmospheric pressure pushing down the liquid, so we're able to get it to boil at a lower temperature. However, if we increase the pressure over liquid, such as using a pressure cooker, say cook rice or pasta, because we're increasing the atmospheric pressure and we have to get the vapor pressure up higher, our boiling point then has to increase. So just get this part down in your notes and then we'll go over this section a lot more tomorrow. Alright, so like I said in the very beginning, while we're dealing with vapor pressure, we're specifically going to be working with table H. So there's two things I want you to be able to observe by using table H. First off, if we increase the temperature, we're going to get a greater vapor pressure. And this goes for any of the four liquids on table H. When I increase the temperature, we get an increase in the vapor pressure. The particles have more energy and are able to evaporate at a faster rate, and thus they push up with a greater pressure, which means that we have a greater vapor pressure. The other thing is that we can use this table H in order to analyze attractive forces, or IMFs. So at a given temperature, the stronger the attractive forces, the lower the vapor pressure. So if we look at any given temperature, propanone, so say I pick right around 75, propanone, which is the highest one, highest vapor pressure, has the weakest attractive forces, while ethanoic acid, which will be at the very bottom, with the lowest vapor pressure, is going to have the strongest attractive forces. So this is something that you just have to know and be able to, again, observe and figure out using table H because it comes up in questions. You can kind of see this here. If we're dealing with intermolecular forces, the weakest IMS is always going to be propanone because it's going to have the highest vapor pressure at any given temperature. Alright, some questions that you need to be able to solve. What is the vapor pressure of a certain liquid at a certain temperature? So, for example, if I look at ethanol at 40 degrees Celsius, I'm simply going to start at my temperature on the x-axis, start at 40 degrees, I'm going to go up to ethanol, and then I'm going to go over to the left to the y-axis to record the vapor pressure, which will be about 18 kilopascals. Alright, another question is simply, what's the boiling point of a liquid at a given pressure? So for example, what is the boiling point of water at a pressure of 130 kilopascals? So in this case, I'm going to go to 130 kilopascals, because remember, when vapor pressure is equal to atmospheric pressure, it will boil. I'm going to go over to my liquid, in this case water, and then go down to the x-axis to record the temperature that this would occur at, which in this case is 107 degrees Celsius. And finally, another common question is, what's the normal boiling point of a certain liquid? The normal boiling point is the boiling temperature at standard pressure. Standard pressure, which is on table A in your reference tables, is 101.3 kilopascals. So if I use that dotted line, I can go across to each of my liquids and simply go down from that point to record the temperature. So you can see, for example, propanone's standard or normal boiling point would be about 55 degrees. You can see water here at standard pressure is going to be 100 degrees, which is what we would expect. Okay, so again, you should get hopefully a little kind of oversight on table H. we'll go into that more tomorrow. You are all set.